Progress update from the Wild Deep. Today we'll be looking at the development of Nova's new torso frame. As you know, the main priority of the Wild Deep research facility is the creation of artificial life. That is, Project Nova, the anthropomorphic wild dog synthetic, or Synth for short. We're also working on some aquatic mining technologies to pay the bills. When I acquired this abandoned mining base, I didn't realize how much of the place needed repairing. It feels like every few weeks we get another flooded compartment. It's been quite the money pit. But our main priority remains Nova. Anyway, back to the update. If I'm going to create a mine for Nova, then she's going to need a body to reside in first. Over the past few weeks, I've been drawing up Nova's schematics, specifically the schematics for her arms. If you go back to my previous updates, you'll see that the original hand design was rather flimsy, very wobbly too, and a far cry from a piece of precision engineering. I'd be stuck recalibrating the finger positions with every power cycle if I kept that one. But that is what 3D printed prototypes are for, finding design flaws before they enter production. I should have the arms built and ready for testing soon. However, all of this leaves me with a problem. What on earth do I attach them to? Of course, I could spend months creating a flexible spine, rib cage, and shoulder blades to make a functional torso, but I need something immediately. So, what do I use instead? It needs to be something strong, rigid, and easy to modify if I need to change the design. For the answer, I took inspiration from the 3D printer I've been constructing, and settled on building a frame out of aluminium extrusion. This will act as Nova's temporary torso while I develop a more permanent solution. The silver beams you're looking at are 40/40 aluminium extrusion, bolted together with steel fasteners. Nothing needs to be welded in place, so I'm free to rearrange the parts and swap out pieces as my designs change. I've used the same approach in her arms, which were made using aluminium extrusion as the bones. It's light and strong enough to keep its shape without bending or buckling under heavy load. You'll notice the two diagonal braces I've attached to the base of the frame, and the two just below the shoulder mounts. These additional lengths of extrusion reinforce the structure by forming triangles as they meet two adjacent lengths at right angles to one another. Triangles are considered to be the strongest and most stable geometric shapes in engineering. This is because the triangle is the only polygon which can't change its shape without changing the length of one of its sides. In practical terms, this means that the triangles will hold the structure in place. This reinforcement should allow the frame to remain rigid when she moves her arms or manipulates heavy objects. For example, if Nova were to use her right arm to pick up a 5 kilogram weight, this would put a great deal of force onto the rightmost shoulder mount of the frame. The diagonal brace below the shoulder helps to support the load and prevent the shoulder mount from bending downwards. Similarly, the diagonal braces by the base of the frame prevent the central spine from swaying to the left or to the right. The torso frame acts as a stable base, which the head and limbs can be attached to. Mounting the head shouldn't be too much of an issue. I can simply bolt the skull to the top of the spine to begin with, and later add joints for neck movement. As for the shoulders, those are going to take some planning. Shoulders are a marvel of biology, with a huge range of movement, but also stable enough to hold their position firmly. Faithfully mimicking our own biology with mechanical parts will be a challenge, but one worthy of solving. With that, I shall see you in the next update, where I'll be showing you the design of Nova's new hands.